Okay, the next unit is similarity. So we're going to start off with similarity by talking about ratios and proportions. We start off with some word problems, kind of. So first off, a definition: a ratio, as a definition of a ratio, is a comparison of two numbers by division. Okay, so the way we read it is the ratio of A to B can be written in two different ways. One is A colon B. We read that as A to B. Or we can write it as A over B. Okay, as a fraction. So it's either A colon B, we read that as A to B, or the fraction we also read as A to B. We just write it as a fraction. A proportion, so here's another definition, is two ratios that are equal to each other, or in some cases that are just set equal to each other so we can solve. Okay, so if two ratios A to B and C to D are equal, then A over B equals C over D. That's called a proportion. And we can essentially solve this proportion by cross multiplying. D times A gives us AD, and B times C gives us BC. So if it's a proportion, then AD will equal BC.
Why were they in this game?
Because we're going to use it.
Because my brother's.
Okay, so example 1 says determine if the ratios 4 to 5 and 3 to 7 form a proportion. So we write 4 to 5 equals 3 to 7. Okay, that's basically how we started. And the way we check to see if it's a proportion is we cross multiply.
And see if
So it's bottom right times top left. So 7 times 4 gives us 28.
See if they both equal the same.
5 times 3 is 15. Does 28 equals 15?
No.
So they're not equal, and so they do not form a proportion. No
That's easy.
proportion. Or not, I guess I should say not a proportion. Because those fractions are not equal. I wanted to. Okay. Determine if the ratios 11 to 5 and 33 to 15 form a proportion. So we write 11 over 5 equals 33 over 15. We cross multiply, so 15 times 11, this is where the calculator is going to come in really handy. 15 times 11, and we should get 165. And we do 5 times 33, which is also 165. So since those are equal,
So yes, it is.
then this is a proportion. Yes. It is a proportion. So proportions can be used to solve a lot of problems involving variables and ratios. Okay. So it says solve for x in this proportion. 3 to x equals 5 to 4. So we write this as 3 to x equals 5 to 4. Notice the first number is the numerator, the second number is the denominator. Now we cross multiply, so 3 times 4 gives us 12. X times 5 gives us 5x. And now we can solve that equation by dividing by 5. So x must be 12 over 5, 12 fifths. Another example of solving an equation with proportions. It says solve for x when the ratio of 4x minus 1 to 5 is equal to x to 4. So 4x minus 1 to 5, notice I just write it as one fraction, 4x minus 1 is the numerator, 5 is the denominator, is equal to x to 4. So we cross multiply. So we have 4 times 4x minus 1 equals 5 times x. Okay, so we have to do some algebra here before we can start solving. We need to distribute the 4. So we have 4x minus 1 4 times. So we'll have 4 times 4x, which is
8x.
16x.
I'm thinking about 4 times 2.
Okay, and then 4 times minus 1 is minus 4 equals 5x. Okay, so solving this equation now, 16x minus 4 equals 5x. So algebraically, we would add 4 to both sides. So we get 16x equals 5x plus 4. Subtract 5x from both sides. And so we get 11x equals 4. And then what's the final step? Divide by the coefficient, divide by 11. And so we can say x is equal to 4 over 11, or 4 elevenths.
That was a long.
What's that? Uh-huh. No, we just, you could get a decimal if you wanted to write as point, I think it's 0.4444, plus fractions are just Now, in word problems, there's a lot of different ways that two variables can be related to y equals kx, where k is called a constant of proportionality. Okay? Y equals kx is a proportional relationship. Notice if we solved for k, to find that constant proportionality, we would divide both sides by x, and k would equal y divided by x, which is a ratio, y to x. So the constant proportionality is the ratio of y to x. And this can be written in a lot of different words. Y varies directly as x, y to x. Y varies as x, y to x. Y is directly proportional to x, y to x. Y is proportional to x, y to x. Y varies linearly with x, okay? So such problems are easily solved with the proportion y over x equals y over x. Okay? Now, these are different values of y, different values of x. We're going to keep them separate. So I'm going to say y1 over x1. In other words, the first x and the first y equals y2 over x2. Okay, so those little numbers aren't multiplied. It's just a way of keeping track of the two different x's and y's.
So that's sort of like the slope formula.
It has the same reason for naming them that way, but it's nothing like the slope formula, as far as the slope formula itself.
So they got that for that, right?
No, the numbering is just a way of keeping track of your x's and y's. Okay, so example 5. Ed, would you read example 5 for us nice and loud, please?
Benedictine monk can copy 8 manuscripts in 5 days. How many days will it take him to copy 31 manuscripts?
Okay, so a Benedictine monk is a monk out in a monastery. Benedictine is an order of monks. Manuscript is when you're writing out by hand.
Isn't it long?
Okay, so the Bible and all kinds of books, before we had printing presses, the way that they were disseminated to people, people hand wrote them. You'd have a Benedictine monk sitting there copying their Latin version of the Bible. They copy it over and over, and then finally, after they've written all 2,500 pages, they turn it over to the next guy and say, "Here you go. Here's your copy of the Bible." And they go to the next one, and they start copying again. People would spend their entire lives doing nothing but copying by hand. Well, they couldn't, right? That was part of their job, so they had to learn how to write. That's why if you look at old manuscripts, everything's so pretty looking, even though you don't understand what the words are because it's in Latin. But it looks really nice because. Okay. Yeah, more than that's entirely possible. So anyway, so he can copy 8 manuscripts in 5 days. It says how many days will it take for him to copy 31 manuscripts? So the proportion we want to use here is we've got manuscripts to days. I'm going to say M over D. So the number of manuscripts to the number of days. So I'll call this the first M1, D1 equals M2, D2. So the initial ratio that we're given, 8 in 5 days, is 8 to 5. Okay, so it takes 8 manuscripts, or 5 days to do 8 manuscripts. So we have 8 over 5 equals. Now the question says how many days will it take for 31 manuscripts? So we have 31 over, I'll just call it D2. Okay. So we can cross multiply. So D2 times 8 is 8 D2. Cross multiply. 5 times 31 is 165. 155, I'm sorry, 155.
I was about to say.
Okay. And so we divide by 8 on both sides. And so D2, put that in your calculator, 155 divided by 8. Oh yeah, that's right, I remember that. So we get
30.375.
19.375 days. Is it possible to have 0.375 days?
Yes.
Sure, right? We don't have to have, it doesn't have to take a whole day to do something, right? Okay. Next example. Says if the blues are directly proportional to the reds, and there are 5 blues when there are 19 reds, how many reds can be expected when there are 15 blues? Okay. So let's look back at example 4 really quick. Okay. Now notice in example 5, the Benedictine monk can copy 8 and 5. How many will it take for him to copy 31? So you have to recognize that that's a proportion since you're given 2 bits of information. On the next one, it's telling you it's a proportion by using these words, directly proportional. If you see that, that means, oh, I've got to set up a proportion. I'm going to have a fraction equals a fraction. So we've got reds to blues. So this is like y to x. So B1 over R1 equals B2 over R2. So the number of blues to the number of reds is equal to the number of blues to the number of reds. So it says there are 5 blues when there are 19 reds. So the first ratio will be 5 to 19. And that needs to equal, says how many reds can be expected when there are 15 blues. So do we know B2 or R2? And B2 would be 15 over R2. So we cross multiply, so we get 5 R2 equals 285, 15 times 19. And so we divide both sides by 5. And there are 57 blues. Reds. R for red.
Answer.
So look for those kind of words, directly proportional. Any of these phrases tell you you'll be setting up a ratio of the first one to the second one. You'll set up a ratio and then a proportion by setting those 2 ratios equal to each other. Okay. Last example, in a poll just before the election, it was revealed that the ratio of those in favor of Senator Cheatham and Steele to those against him was 3 to 5. At this rate, how many votes can he expect from 100,000 voters on election day? So, first off, we're told a ratio, right? The ratio, so that's a big hint, right? That we're to set up some kind of a ratio of those against him. I'm sorry, those in favor to those against is 3 to 5. Okay. So how many are in favor of him?
3.
Out of how many total? So are we just talking about 5 people here?
No.
If there's 5 against him and 3 for him, how many total are there? 8. So we've got 3 plus 5, which is 8 total voters. So our ratio here will be those against him, those in favor of him, I'll use an F, to the total. Okay, because we're told there's 100,000 voters. Not 100,000 people against him, 100,000 total voters. So we have those in favor over total, so I'll say F1 T1 equals F2 over T2. So how many are in favor of him? Out of how many total?
8.
Okay, so we're looking for how many
Thank you.
will vote for them. Are those in favor? Well, those would be in favor of it, right? If they vote for them. So we're looking for how many are in favor out of 100,000. This is how polling works. They figure out a ratio of people for out of the total, and then they can make a pretty good guess at how many people actually vote for that person. So we cross multiply. So 100,000 times 3 gives us 300,000 equals 8 times the number in favor. So we divide both sides by 8. And so what do we get for the number in favor of them?
37502.
37502 zeros? So 37,500 people will vote for him? So notice the calculators can come in handy here as far as doing calculations. Not for a whole lot more than that though, right? Okay, so you got some practice. Got the remainder of the period to work on.